So Oracle SQL is providing constraints like primary key, unique, not null, check constraint, and default constraint, and foreign key constraint. So these are the foreign key, or you can say references. Foreign key or references. So these are the 6 constraints provided by the Oracle SQL. Primary key means it does not accept duplicate values and null values. Unique means does not accept duplicate values but accepts the null values. Not null means does not. If you want to apply default value to a column, default. If you want to accept primary key values of another table, references. So these 6 we have seen practically. Now listen carefully. Continuation of constraints. I want to talk some important points regarding constraints at 2 levels. We can apply these constraints at 2 levels. First one is column level constraints. Second one is table level constraints. So in the previous session, we have seen these 6 examples, that is applying at column level. Till now, we didn't apply at table level. In the previous session, we have seen examples on these 6 constraints. We applied constraints at column level. So we can apply constraints at 2 levels. We can apply constraints at 2 levels. One is at column level and another one is at table level. Column level we can apply, table level we can apply. What is this column level, sir? Column level means if constraint is applied in field definition, if constraint is applied in field definition, then it is called column level constraint. Then it is called column level constraint. For example, we are writing like this. See, for example, we want to create one student table. We are writing like this. Create table. Table name I am giving as student. First field SID. I am giving number data type size as 4. And I want to set primary key. So what we are writing? Primary key we are writing. So now this one is called column. Here primary key is called column level constraint. When we are defining the column definition or field definition, in the field definition itself, we are defining the constraint. So field definition means I already told column name, data type, constraint, constraint name, constraint type. That is called column definition or field definition. So here I am not giving constraint names, this field name, data type, this is constraint type. We are applying this constraint in the column definition only. That's why it is called column level constraint. S name. Okay, this is varchar2 type. We are applying not null here. Now this is called column level constraint. In the column definition only, we are defining the constraint. This is called column level constraint. So which constraints we can apply at column level, sir? All 6 constraints. All 6 constraints can be applied at column level. All 6 constraints can be applied at column level. What are those 6 constraints? Those are primary key. Shortly I'm writing PK. Sorry. Unique, not null, check, default and references. Default and references. All these 6 constraints we can apply at column level. So in the column level, we can apply all these 6 constraints. So in the column definition, if we define the constraint, that is called column level. Then what is table level, sir? Listen carefully. Table level constraint means if constraint is defined, after defining all columns, if constraint is defined after defining all columns, then it is called table level constraint. After defining all columns, if constraint is defined after defining all columns, so first we define all columns, after that we define all constraints. So after defining all columns, if we define the constraints, those are called table level constraints. Okay, so at table level, we can only applied at constraints only can be applied at table level. They are, first one is primary key, second one is unique, and third one is check, and fourth one is references. References means foreign key. Only these 4 constraints we can apply at table level. Okay, remaining 2 constraints cannot be applied at table level. Cannot be applied at table level. After defining table level, for example, we are defining like this. Observe here. See, we want to create one table. Okay, student 6 table. So table name is student 6. Third name is M1. Okay, SID which type? Number data type. I want to apply primary key at table level. So primary key we want to apply at table level now, not column level. We want to apply this constraint at table level. Okay, column level means we write like this. Field name, data type, then beside of the data type, we are writing primary key. This is called defining primary key at column level. Now we want to define this primary key at table level now. How can we define table level? Now in this example, we see. Next, sname. Sname which type? Varchar2 type. So Varchar2 type, I'm giving size as 10 and I want to apply not null. Can we apply not null at table level? No. Not null and default cannot be applied at table level. For columns only we apply. So that's why not null we apply at column level only. We cannot apply it table level. So that's why I'm applying it column level only. Next, M1 field is there. M1, which type? Number type. I'm giving size as 3. And I want to apply check constraint. I want to apply this check constraint at table level. Table, what is the table name? Student 6. Student 6. What is the first field name? SID. Which data type? Number data type. So number of 4. Okay. Don't define primary key here. If we define primary key here, this one is called what? Column level constraint. But we want to apply it table level. Table level means first we define all columns. After defining all columns, we define the constraints. Okay. Next field. S name. Which data type? Varchar 2 data type. So we are giving size as 15 here. Okay. Next, I want to apply not null constraint. Can we apply not null at table level? No. That's why we are applying it column level only. In the field definition only, we are defining the constraint. Next, third field M1. Number type. I'm giving size as 3. Now, all field definitions are over. Observe. After defining all fields, now define the constraints. These constraints are called table level. Now all column definitions are over. Now we want to define primary key. So here write primary key. Primary key. This primary key we want to set for which column we have to tell. This primary key we want to set for which column we have to tell. Which column we want to set? SID. Okay, if you want to apply constraint name, you can write here. You can write constraint name, you can write. But I don't want to apply any constraint names as of now. So just I am applying constraint type here. Primary key, we are setting for which column? SID column. So whereas if you write this primary key here within the column definition only, we are defining primary key here. So again, we have no need to tell the column name. So for SID column only, we are applying primary key here. Again, we have no need to tell the column name here. But whereas here, after defining all columns, we are defining the primary key. So 3 fields are there. To which field you want to set primary key, you have to tell here. So to which field we want to set primary key? SID. So write SID here. SID, comma. We want to apply check constraint now for M1. So what we write here? Check. M1 value must be greater than or equals to 0 and M1 value must be less than or equals to 100. This is check constraint. We are applying at table level. Okay, that's it. Here, after defining all columns, we are defining primary key constraint and check constraint here. This is applying at table level. So in this example, here we are defining primary key and not null. This is called column level. Column level means within the column definition, we specify the constraints. Here we are defining the column, field name, data type. Here we are defining the constraint type. In the column definition itself, if we define the constraint, that is column level. Now, whereas in this example, here, first we are defining all columns, 3 columns we are defining. At the end, we are defining primary key and check constraints. This is called what? Table level. So this one is called table level. After defining all columns, if we define the constraints, we call that as a table level constraint. So at table level, we are applying primary key and check here. And this not null, we are applying it column level only because not null cannot be applied at table level. Okay. So like this, we can define the constraints at 2 levels. For example, tomorrow, if you want to apply unique for the SID, instead of writing primary key of SID, just simply what we have to write? Unique of SID. So now here, this SID we are defining as the unique. Instead of writing primary key, if you write unique here, this is applying unique constraint at table level. Now you know 3 constraints how to apply at table level. One is primary key of column name we specify. Check condition we specify in the parenthesis. If you want to apply unique constraint, write unique, then in the parenthesis specify column name. Now, is it working or not? Just we want to check. Observe here. I'm copying this. Open SQL Plus. Okay. For our batch, username is batch 2 PM. Password is Naresh IT. I'm setting page size as 200, line size as 200, and I'm clearing the screen. CL space SCR. It clears the screen. Now observe here. I'm copying this. This create query I'm copying. In the previous session, already we defined constraints at column level. Now we are defining primary key and check constraints at table level with this example. Observe. See here. After defining, after defining all columns, here we are defining constraints. This is called table level constraints. Okay, now is it creating table or not? Just observe here what it is telling. Table created. What is the table name? Student 6. So in this SID, we are applying as primary key at table level. For M1, we are applying check constraint at table level. For SName, we are applying not null at column level. Okay. Now, listen. Is it working or not? Is primary key working or not? We want to check. So insert into table name is student 6. Values. Give the values here. Student ID 1. Name is A. Marks are 50. Now, is it accepting this record? Observe here. Yes, accepting. One more record I'm giving. Okay. 1B70 I'm giving. Is it accept this record? No, it will not accept this record. Why? Because this is creating the duplicate value. Primary key does not accept the duplicate value. So it is giving the error here. Observe what it is telling. Unique constraint violated. Now here, what is this sys_c? What is this sys_c? Constraint name. This is constraint name. What is this C ## batch 2 PM? Schema. Or schema can be also called as user. This is a user name and this is the constraint name. Sys_c is the constraint name. We didn't give any constraint name. So by default, Oracle is giving the constraint name. Next. I'm trying to insert null value in the primary key. Is it accept this record? No, primary key does not accept null value. It is demanding for the value. So you cannot insert null. You cannot insert null into batch 2 PM user, student 6 table, SID column. Okay, so primary key is working perfectly. Next, for SID we applied not null. I'm giving student ID as 2B70. Does it accept this record? Yes, record will be accepted. One more record I'm inserting, 3. The student name is also A. Okay, his marks are 50, 70 marks, same 70 marks. Okay, now does it accept this record? Yes. Okay, student name, duplicate value we are giving. Not null can accept the duplicate values. This record will be accepted. Not null does not accept null values. For example, I'm trying to insert null value here. Okay, now does it accept this record? No, because we are trying to insert null in the SName. SName we applied as not null. Not null does not accept the null values, but you are giving null value, it is giving error. So what it is telling, observe here, cannot insert null into batch 2 PM user, student 6 table, SName column. In the SName column, you cannot insert the null. Next, final one, check constraint working or not, we want to check. So I'm giving student ID 5. Okay, some name I'm giving. So marks I'm giving as 567. Is it accept this record? No. Why? Because of check constraint. Check constraint we applied here. It can accept values between 0 to 100 only. Okay, we are giving 567. So check constraint violated. So now in this example, we applied primary key check constraint at table level. Okay. So very, very easy. If we are defining the constraints in the column definition, that is called column level. After defining all columns, if we define all constraints here, that is called a table level. Okay. So both are same, both acts as same. The only difference is in table level constraints, we define all fields at a time. After that, we define all constraints at a time. This is the only flexibility we are getting here. That's it. Okay. Beyond that, no difference is there. Both acts as same. For both, we are applying constraints only. Okay. Both acts as same. Just after, first we define all columns. After that, we define all constraints. This is the flexibility we are getting. Next. Now, I want to apply foreign key at table level. I want to apply foreign key at table level. So when you are referring the books or websites, at that time, some authors may follow this style and some authors may follow this style. So if author is defining like this, you can understand that this is table level. If author is defining this primary key in the column definition, you can understand that that is column level. So for understanding purpose only, we are discussing this one. Okay. So how can we apply foreign key at table level? See, I want to create one table here. Yesterday we have seen same example, course 1 table. Course 1 table we are creating. Course ID and course name. Course ID 10, course name is Java. Course ID 20, course name is Python. 30, Oracle. Like this, we want to create one course table. And here we want to apply course ID as the primary key. And these primary key values we want to accept in another table. This table name is student 7. So in this table, we want to accept student ID, student name, and course ID. Here course ID we want to set as the foreign key. Here course ID we want to set as the foreign key. If we set as the foreign key here, the advantage here is it accepts only these primary key values 10, 20, 30 only in this course ID. For example, I'm giving 30. 30 means this person is learning which course? Oracle. 1002 person learning 10th course means which course is learning? Java. 1003 person is learning 80th course means which course is learning? This is invalid data. So we want to restrict the user from entering invalid data. So it raises error if you set this as the foreign key. Now, in this column, it accepts only course tables, course 1 tables, course ID values only accepted here. So this course ID refers to course table, course ID, primary key values. Only these values will be accepted here. Other than these values, if you give, that will not accept. Okay. So here course is not there. How a student can join in the course? So that's why we don't want to allow such type of data. So we set this as the foreign key. I want to apply this CID in the course table, course ID. I want to set as primary key at table level. And this foreign key also I want to set at table level. So how can you apply foreign key at table level? We are discussing now. Observe. So create table. Table name is course 1. The course 1 fields are course ID, number type. What is the size? What is the size here? Size is 2. 10, 20, 30. Size is 2. Course ID, number type, size we are giving as 2. Next course name, varchar 2 type. I'm giving size as 10. And I want to apply primary key at table level. So after defining all fields, we are defining primary key here. To which column? CID column. That's it. So we are defining primary key at table level. Observe now. Is it creating table or not? Just observe. See, table is created. Here we are applying primary key at table level. I want to insert the records. So to insert the records, write insert into course 1 values. I'm giving values as 10 Java. Okay. So one row will be created. Next, we are giving 20 Python. Now another row will be created. One more record we are giving 30 Oracle. 30 Oracle. One more row is created. To save this table data, what we have to write? Commit. Commit means data will be saved. So we are inserting records here. So 10 Java inserted. Next, one more record we are inserting 20 Python. 20 Python. Okay. Next, one more record we are inserting 30 Oracle. 30 Oracle. So after inserting all records, to save this table data, what we are writing? Commit. To see this table data, what we have to write? Select star from table name. Table name is course 1. Course 1. It displays table data. Observe here. Select star from course 1. Observe. It is displaying course tables data to us. Now, what is our requirement? We want to set foreign key for student 7 table. This one. We want to create student 7 table now. In this SID, SName, and this CID, we want to set as the foreign key. This is our requirement. Foreign key, we want to apply at table level. So write create table. Table name is student 7. Student ID, which data type? Number data type. Student name, varchar2 data type. Okay, next third field, CID, number data type. Now this CID we want to set as the foreign key. Okay, so if we want to apply this CID as the foreign key, we have to write like this. Here we have to use one keyword, foreign key. For column level constraint, directly we are writing references. So if you want to apply at column level, what we write here in the column definition itself, we write references. References. Which column values you want to accept here? Course 1 tables, course ID values. Okay. Here, which column values we want to accept? Course 1 tables, course ID values we want to accept. So that's why what we write, references, course 1 tables, course ID values. So now in this column, it accepts only course 1 tables, course ID values. Other than those values, if you give, it raises error. So this is defining constraint at column level. But we don't want to apply at column level. We want to apply table level now. So at table level also we write like this only. But if we write like this, you want to apply these references to which column it cannot understand. You want to apply references constraint. Okay. You want to accept course 1 tables, course ID columns. Okay. In which column? In SID or in SName or in CID? It cannot understand. Because of that reason, here we use one keyword, foreign key. Foreign key we want to set for which column? CID column. Apply foreign key for the CID column. And in this CID column, it refers to course 1 tables, course ID values. That's it. This is applying foreign key at table level. When you are referring books or websites, if author is writing like this, you can understand that this is table level. For this understanding purpose only, we discussed about table level. That's it. So now, is it creating table or not? Observe here. See, table is created. Now, let me insert records into the student 7 table. In the student 7 table, we are inserting one record. Insert into student 7 values. 1001 student A. The student joined in 30th course, means Oracle. He joined in Oracle. Observe. Is it accepting record or not? Just observe. Yes, accepting the record. For example, 1002 student, B student is learning 70th course I am giving. Okay, is there this value available in course 1 table's course ID? No. In course 1 table, course ID, only 10, 20, 30 values are there. Only those values will be accepted here. You are giving other than those values. So it gives error here. It's giving error as integrity constraint violated. Here batch 2 PM is the schema name. sys_c. 6-digit random number is called constraint name. So this is applying foreign key at table level. So if you write like this, it gives error here. Integrity constraint violated. So this is about table level and column level. After defining all fields, if we define the constraint, that is called at table level. So first we define all fields. After that, we define all constraints which we want. This is the only flexibility we are getting. Beyond that, nothing is there. So finally, we can apply the constraints at table level at 2 levels. One is column level, and another one is table level. In the previous session, we defined all 6 constraints at column level. In today's session, we applied these constraints at table level. Here, primary key check we are applying at table level. If you want to apply unique, instead of writing primary key, write unique here. Unique will be applied. If you want to apply foreign key at table level, we write like this. Okay. So this is about applying constraints at table level and column level. Okay. Yes, please, all of you confirm. Is it clear till here? Next. See. Next one is naming constraints. Topic name is naming constraints. Just a minute, please wait. So, SQL is providing 5 sub-languages to us. Among those, first sub-language is DDL. So, we are discussing about DDL commands. In the DDL commands, we are discussing the first command, create command we are discussing. Observe. So this is the syntax of creating table. So this is the syntax of creating table. Okay, observe. Observe this syntax. Now you know very clearly about data types and you know very clearly about constraint types. So to create the table, see, to create the table, we are following this syntax. Field name, create table, table name, opening parenthesis. So this is called one column definition. Column definition means field name, data type, constraint, constraint name, constraint type we use. So you already know how to use the data types. Just like in the previous examples, we have given SID. SID is what? Field name. Okay. Number is what? Data type. Okay. We are giving primary key here. Primary key is what? Constraint type. But till now, we didn't give any constraint name. So this topic we are discussing now. Constraint names. Okay. How can we give the constraint names? This part we are discussing. See, when we are defining the constraint, as an SQL developer, we have to give this constraint name. Okay. So when we are defining the constraint, we have to give this constraint name. If we don't give the constraint name, implicitly Oracle gives one name by prefixing 16-digit random number with sys_c. Observe here. See, in this example, here third field is course ID. Course ID is the foreign key. So if you are entering other values of course 1 table's course ID values, it is raising the error. When it is raising the error, observe here what it is displaying. C # batch 2 PM. This is schema name. What is this one? This _C 160 random number is there. What is this one? This is called constraint name. So when we defined this table, we didn't apply constraint name. So that's why Oracle is giving constraint name. So when we are defining the constraint, we have to give one constraint name. If we don't give the constraint name, Oracle gives the constraint name. So topic name is naming constraints. We can give names to the constraints. We can give names to the constraints. If we don't give the name, if we don't give constraint name, implicitly Oracle gives constraint name. Okay, when we are creating the table, it's better to give the constraint name. If we don't give constraint name, implicitly Oracle gives constraint name. This implicitly defined constraint name is a 6-digit random number. A 6-digit random number will be prefixed with sys_c. Implicitly defined constraint name is defined as a 6-digit random number, and this will be prefixed with sys_c. For example, like this. sys_c. 1 6-digit random number is there. This is one constraint name given by the Oracle. Okay, not only this number, randomly it gives different 6-digit numbers. For that will be prefixed with sys_c. If any 6-digit number is prefixed with sys_c, you can understand that this is constraint name, implicitly given by the Oracle. Then what is the need of giving names, sir? What is the need of giving names? If we give the names, the advantage here is, listen. For example, today we are creating this table. For example, I'm taking student table here. So in this student ID student name and marks of subject 1. Here the student ID is the primary key. So primary key means, does it accept null values? Primary key means, does it accept null values? No. Okay. For example, one student joined here. One student joined. I know his name. I know his city name, but I don't know his student ID because college didn't assign student ID to him. Temporarily, I want to accept null value. So primary key means, is it accept null value? No. But temporarily, I want to accept null value. No. So temporarily, we want to accept null value. We want to accept null value. So what we have to do? Okay, we disable the primary key. Disable the primary key. So what we do now? We disable the primary key. If we disable the primary key, now primary key will not work. So it accepts the null value. In the future, college is assigning one student ID to him. I'm entering that student ID. Now after this, again, we can enable it. Okay. If you want to enable the primary key, okay, after some time, we can enable the primary key. If you want to enable the primary key, we can enable the primary key. Now again, primary key will work. So temporarily, if you want to accept the null values or duplicate values, at that time, we have to disable the primary key. To disable the primary key, this name is useful. We write like this. Alter table, okay, table name. Okay, if you want to disable the constraint, we write disable constraint. If that primary key constraint name is C1, that constraint name we will give. So this C1 is the constraint name of primary key. For example, I'm taking. So now this primary key will be disabled. Means it can accept the null values now, duplicate values now. Temporarily, primary key will not work. So for disabling the constraint, what we are using here? Constraint name. Okay, it is disabled. In the future, we want to enable it. Again, we use the constraint name only. Alter table, table name, enable constraint. Enable means again it will work. Enable constraint, constraint name. No, I want to drop this constraint permanently. Permanently, we don't want constraint. At that time, we write like this. Drop constraint, constraint name. Okay, we discuss all these things in the alter command. The point to understand is when these names are useful, when we are using names to disable the constraint, enable the constraint, drop the constraint, we are using the constraint name. That's why names are important. Okay. So constraint names are useful to disable or enable or drop the constraints. So if you want to disable the constraints, means temporarily that constraint will not work. Again, disabled one, in the future we want to enable it. Again, it will work. Now, we want to drop the constraint. We can permanently drop the constraint. For all these three things, this constraint name is required. So constraint names are useful to disable or enable or drop the constraints. Okay. And one more point. All constraints information will be stored in one table. All tables information will be stored in one system table. What is that one? What is that one? User tables. User tables is one system table that maintains all tables information. Like that, user views, it maintains all views information. Okay, user sequences maintains all sequences information. Like that, user constraints maintains all constraints information. So user constraints means it displays the constraints list which are created by one user. So user constraints maintain all constraints information. All constraints information. Okay. So we write like this. Observe. For example, so who created this user constraints table? Who created this user constraints table? Oracle developer. We don't know the table structure. So if you want to see the table structure, what we have to write? Describe. Describe. What is the table name? User constraints. Describe user constraints. This user constraints table has all constraints information. Because, for example, I want to drop this table we created. Course 1 table we created. This course ID is the primary key. I want to disable this one or enable this one, or I want to drop this constraint. No name is required, but we don't know this name. So how can we see the name, sir? Using this user constraints, you can see the name. Observe here. See, describe user constraints. User constraints, observe. These many columns are there. Among these important columns are these three. Constraint name, constraint type, table name. These three are important here. Constraint name, constraint type, table name. So constraints information maintained by which table? Constraints information maintained by which table? User constraints. So it is maintaining constraint name, constraint type, and table name. Okay. So if you want to get employee number, employee name columns from EMP table, we are writing like this. Select employee number, e-name from EMP we are writing. And what is EMP here? Table name. What are employee number, e-name? Column names. Okay, like that. Here from user constraints we want to retrieve. So write user constraints here. Which columns you have to tell? Which columns? Constraint name column data we want. Constraint type column data we want. And table name column data we want. So 3 columns data we want. So select constraint name, constraint type, table name. From which table? From user constraints table. Okay. So observe here, it displays constraint names. Observe. Okay. So let me set line size here. Line size I'm setting as 2000. See, observe here. Till now, we didn't give any constraint name. All constraint names are prefixed with sys_c. Observe. 160 random number is there. Here constraint names and constraint types are there. Today we created student 7 table references. References we applied. References foreign key. Okay. And we created course 1 table. In the course 1 table, course ID is the primary key. Today we created. So these primary key values only we are accepting in this references, in this foreign key. Today we created it. Okay. And the student 6 also today only we created. Okay. So like this, for unique, it will display constraint type as U, for primary key P, for check constraint C, for not null also C. Like this, it will display constraint type as one character here. Okay. So if you want to know this constraint name, in the student 7 table, this course ID you are setting as a foreign key. If you want to know this constraint name, just you can see in this table list. What is the table name? Student 7, foreign key, references, constraint type. What is the constraint name? This is the constraint name. Like this, we can know the constraints information. Okay. So all constraints information stored in the user constraints table. Now listen. I want to create one table now. Observe. Creating table using constraint names and constraint types. We want to create the table using constraint names and constraint types. Observe. I want to create one table. Table name is student 8. First field is SID. Second field is SName. Third field is M1. SID which data type? SID which data type? Number data type. I am giving size as 4. And I want to apply primary key. Primary key is the constraint type. And for this constraint type, I want to give constraint name as X. X is the constraint name. Okay. So generally in the real time, they give like this. Okay. If they want to set primary key, PK underscore table name. Like this, they write. They give the constraint name. PK primary key. In which table you are applying? Student 8 table. So generally, like this, they use name in real time. Constraint type underscore table name they use. I am using just X. X is the constraint name. For SName, varchar 2 data type, I am giving field size as 15. And I want to apply not null here. And I want to give constraint name as Y. Next, M1 field, number data type. I'm giving size as 3. I want to apply check constraint. For this constraint, I am giving name as Z. Here, X, Y, Z are what? Constraint names. Primary key, not null, check. These are what? These are what? Constraint types. These are constraint types. X, Y, Z are what? Constraint names. These are the constraint names. So primary key, not null, check are the constraint types. X, Y, Z are the constraint names. Using constraint names, we want to create the table now. Observe here. So create table. What's the table name? Student 8. SID. Observe this syntax first. See. Create table. I am giving table name as student 8. Student 8 is what? Table name. I am giving SID here. SID is what? Field name. I am giving number of 4 here. What is this one? Data type. So to give the constraint name, we use one keyword. What is that one? Constraint. I am giving constraint name as X. X is what? Constraint name. And I am giving constraint type as primary key. Primary key is the constraint type. Very, very simple. So already we created table by using field name, data type, constraint type. Here extra, we are using constraint name. To give the constraint name, we have to use one keyword, constraint. I already told SQL is completely memory based. We are not writing any logic here. We are not writing any programs. You have to remember this syntax, follow this syntax. So we want to create student 8 table. Field name is SID. Field name is SID. Number data type. So number data type I am giving. Size I am giving as 4. Constraint. Constraint name I am giving as X. X is the constraint name. And constraint type we are applying as primary key. Okay, that's it. One column definition is over. Second column is SName. Which type? Varchar 2 type. Constraint. Constraint name. We are giving constraint name as Y. Not null we want to apply. So write not null here. Next M1 field. Number data type. We are giving field size as 3. And we want to give constraint name Z. So write constraint Z. Check constraint we want to apply. So check M1 greater than or equals to 0 and M1 less than or equals to 100. So in the previous session, we have seen same example, but at that time we didn't give the constraint names. So at that time we didn't give this constraint X, constraint Y, constraint Z was not there. Instead we created same table. At that time these constraint names we didn't give. But now for the constraints we are giving the names. So if we don't give the constraint names like this, implicitly Oracle gives the constraint names by prefixing them, by prefixing one 6-digit random number, by prefixing 6-digit random number with sys_c. These names are defined by the Oracle. Like that, now we are defining our own names. If we give the names, again Oracle will not give the names. If we don't give the names, Oracle gives the names for the constraints. So here we are giving the names. Observe here, is it creating table or not? Just observe. Student 8 table, is it creating table or not? See here, table is created. Student 8 table created with how many fields? 3 fields, SID, SName, M1. For SID, we are applying primary key constraint. Constraint name is what? X. For SName, we are applying not null constraint. Constraint name is Y. For M1, we are applying check constraint. Constraint name is Z. All constraints information will be stored in which table? All constraints information stored in which table? User constraints table. So I am writing this query now. Observe. User constraints table is having constraint names. Observe here. Just now, previously, when we were seeing constraints, it was showing how many rows? 11. 11 constraints names it was showing. Now, how many constraint names it is showing? Observe here. 14. 14. Previously 11. Just now we created 3 constraints. X, Y, Z. Observe here. So in the student 8 table, primary key we are setting for SID. Okay. And for SName we are setting not null. And for M1 we are setting check constraint. Okay. So those 3 constraint types it is showing. For not null also it will show C only. It will show reference type as C only. Okay. Now, observe here. I am inserting the records into this table. This table name is what? Student 8. In the student 8 table, we are inserting the records now. Insert into student 8 values. I am giving 1A. 70 I am giving. Is it accept this record? Yes, record will be accepted here. So one row created, it is telling. Now one more record we are inserting. Now here I am giving duplicate value 1B 60 I am giving. Now is it accept this record? No. Why? Primary key does not accept the duplicate value. So here it gives error. Unique constraint violated it gives. So unique constraint violated it gives. In the brackets it will display schema name. What is the schema name here? Batch 2 PM. What is primary keys constraint name here? What is the primary keys constraint name here? X will be displayed. So this X constraint violated. X constraint means primary key. Observe here. See, insert into student 8 values. Here I am giving another name B and marks I am giving a 60. Now it gives error. It is giving error. Observe. See, unique constraint violated. Unique constraint violated it is telling. Okay, here batch 2 PM is what? Schema name. X is what? Constraint name. We defined this one. Okay. So this is the constraint name. So when these constraint names are useful to disable or enable or drop in the alter command, I covered that one. Next, one more record I'm inserting. Insert into student 8 values. I'm giving student ID as 5, student name as D, and marks as 678. Is it accept this record? Why? Check constraint violated. So check constraint violated error it gives. In brackets, it will display schema name. Your schema name is batch 2 PM. Okay, and constraint name also it will display. For check constraint, what is the constraint name? Z is the constraint name. So that Z name will be displayed here. Okay, observe here. We are trying to insert one record here. So insert into student 8. I'm giving 5, D, and marks value I'm giving as 245. It is more than 100. So check constraint will be violated. Observe. What is the error it is giving? Just observe. Check constraint violated. Here batch 2 PM is the schema name. Z is what? Constraint name defined by us. So we have given this Z constraint name. Okay. So this is about naming constraints. This is about constraints. Complete constraints topic is over. So finally, I'm giving overview on constraints. Observe. What is constraint? It is a rule. Okay. Where we apply on column. So constraint is a rule we apply on particular column. So what are the constraints are available? Primary key, unique, not null, check, default, and references. These references can be also called as foreign key. Okay, primary key does not accept duplicate values and null values. Unique does not accept duplicate values but accepts the null values. Not null does not accept null values but accepts the duplicate values. When we use check to write our own conditions on column, use check constraint. To apply default value to a column, use default. To accept only primary key values of another table, use references. These constraints can be applied at 2 levels. One is column level, another one is at table level. So at column level we can apply, at table level also we can apply. Column level means within the field definition we define. Table level means after defining all fields we define. So at column level, which constraints we can apply at column level? All 6 constraints. All 6 constraints we can apply at column level. Primary key, unique, not null, check, default, references. All these constraints we can apply at column level. At table level, how many constraints we can apply? 4 only. What are those? Primary key, unique, check, references. References, or you can say this as the foreign key. Can we set not null at table level? No. Okay. Can we set default at table level? No. So at column level only we can apply them. Remember this. And last one more point. We cannot give constraint name. We cannot give constraint name. We cannot give constraint name to default constraint. For all constraints, we can give the constraint name. For default constraint, we will not give any constraint name. Remember this. Here name is not required. We have no need to disable or enable. Okay, so that's why we cannot give constraint name to default constraint. So this is about constraints. Constraints topic is over. So this is about create command. Complete create command is over. Okay, observe the syntax of create here. Now you know how to create the table by using this complete syntax, you know now. Table name you know, field name means what you know, data type you know, constraint you know, constraint name you know, constraint type you know. So everything about creating table you know now. So create command is over. In the SQL is providing 5 sub languages. Among those, we are discussing about DDL commands. So in the DDL commands, create command is over. Next command is what? Alter command. In the next session, I cover this alter command. I'm stopping the session here. Thank you, everyone. See you tomorrow. Okay.